Hi guys, welcome to New Wave Coaching Classes for Science. This is your host Jatin. In the previous lecture, we discussed about the different types of chemical reactions. We discussed two types of chemical reactions, that is the combination reaction and the decomposition reaction. So we move a step further. We today discuss about the other three types of chemical reactions. Two you can see on the board. The first one, the third one in the line is our displacement reaction. Now, what does a displacement reaction means basically? Displacement means you're displacing something. It's a very simple thing. You have two things. This is stronger, this is weaker, this removes it. Basically, if suppose this one is stronger, this one is weaker, we call this a displacement reaction. Now, how to understand in terms of chemicals, right? Let's understand in terms of chemicals. What is there? We say a reaction in which a more reactive element displaces a less reactive element from its aqueous salt solution. Now, what does aqueous salt solution means? The solution of the salt is in the water, right? Now, we have an example. We say Fe, when Fe, that is the iron, is mixed with a solution of copper sulfate. Now, generally the solution of copper salts are blue, but copper sulfate solution is little bit darker in color, right? So when this iron, you can say iron nails you have taken and you drop some of the iron nails in the copper sulfate. So what happens? Initially the color of the solution is blue, but after some time the color of the solution becomes light green due to the formation of ferrous sulfate, and copper is displaced. Now what happens here? This iron is more reactive than copper. So what happens? It comes at this place and this thing is taken out. So that is why we have FeSO4 plus Cu, right? Let's take one more example. If we drop zinc in copper sulfate solution, then what happens? Same thing, since zinc is more reactive, this zinc is more reactive than copper. So what it does, it comes here and this is removed, right? So when this zinc is dropped in copper sulfate solution, so what happens? We get zinc sulfate and the copper is removed. And how we come to know that reaction is completed? Initially the color of the solution is blue, but later on it becomes white, right? And let's take one more example. Similarly, if we drop zinc in ferrous sulfate solution, now again this zinc is more reactive than this iron. So it comes here and iron is removed from here, right? So what we have? Zinc sulfate plus iron. Now initially what happens? Initially the color of the solution is light green due to the ferrous sulfate, but later on when this zinc sulfide is formed, the color changes to white, or we say colorless, right? Now we take another thing. If we have copper and we put this copper in ferrous sulfate solution. So now what happens? Since here the copper is less reactive, this is less reactive than iron. So this copper does not have the strength to remove iron from ferrous sulfate solution. This copper does not have strength to remove iron from copper sulfate solution. So what happens? There is no reaction. We have no reaction. Similarly, if we drop Fe, that is iron, in a solution of zinc sulfate, if we drop Fe in a solution of zinc sulfate, again there will be no reaction because zinc is more reactive and iron cannot remove zinc from its solution, right? So the definition says a reaction in which a more reactive, so these are more reactive elements than these. So when we say more, we are comparing two things. So we are comparing the reactivity of two metals, right? So here Fe was more reactive than copper, so Fe removed copper. Zinc was more reactive than copper, so zinc removed copper. And again, zinc was more active than iron. So zinc removed iron also. So this was all about the displacement reaction. Now we go to the next thing, that is a double displacement reaction. Now what happens in a double displacement reaction? Double displacement reaction, you can say these are two things. They are exchanging their ions, something like this. This is exchange of ions. So they have exchanged the ions. This is what we call double displacement reaction. Or in terms of definition, in terms of chemicals, we say a reaction in which there is exchange of ions between reactants. So initially there were two reactants, right? So what they did, they exchanged their ions. So we have new two products now. So we get two new products, right? So we say a reaction in which there is exchange of ions between reactants is called a double displacement reaction. Now one of the double displacement reaction we have already discussed in the beginning of the chapter, that was the reaction between lead nitrate and potassium iodide. Now what happens in the case of this, when we have the solution of lead nitrate and potassium iodide, both are colorless, but as soon as these are mixed, what we get? We get yellow precipitates. What we get? We get yellow precipitate, and the precipitates are of lead iodide, and we have the solution of potassium nitrate. Then we can take one more example, that is we have a solution of sodium sulfate and barium chloride, right? This AQ in the bracket means aqueous, that is the solution in water. So both of these when are mixed, what happens in that case? They exchange their ions. How they exchange ions? This Na comes with Cl and this Ba comes in SO4 here. So this is what happens. So this is how they are exchanging their ions. So what is formed? NaCl and barium sulfate, right? Now barium sulfate, you can see a downward arrow. A downward arrow means they have precipitates. The precipitates are formed and they are white in color, right? So these are the third and fourth type of reaction. We go to the next one, which is called as reduction and oxidation reaction, right? Now as the name suggests, reduction oxidation reaction. So it means we're talking about something related with the oxygen. So we go to the next one, reduction, oxidation. Before we discuss about the complete reaction, let's discuss some of the definitions. In short, this is also called as redox reaction. It's also called as redox reaction. So redox how? This is RED from here and OX from here, and we combine these two to shorten the name. It's called as redox reaction, that is reduction and oxidation reaction. Why we say this? Because in every reaction there is some kind of reduction and some kind of oxidation, right? Let's understand what is the oxidation and reduction means here. Let's say we have different definitions, separate definition. So now first we talk about oxidation. Now obviously when we talk about oxidation, it means somewhere the thing is reacted with the oxygen, right? So this is addition of oxygen, right? This is addition of oxygen, or what we can say removal of hydrogen, right? Or there's one more definition. If there is no oxygen, there is no hydrogen, then also we can say there is some kind of redox reaction. So the third one we say loss of electrons, right? So this is oxidation. And when we talk about reduction, then it is just the opposite things. If it is addition of oxygen in the oxidation, we say removal of oxygen. Or here it is removal of hydrogen, so we say addition of hydrogen. And in In the oxidation, the third one is loss of electrons. So here it is, or gain of electrons. Right? So these are the definitions of oxidation reduction. Let's understand oxidation reduction in a better way with the help of some reaction. Before I proceed further, there is the thing we have discussed earlier, that is about double displacement reaction. The double displacement reactions are also called as precipitation reactions, because in case of double displacement reaction, one of the product that is forms precipitates. That is why we also call them precipitation reaction. But we can also say any reaction in which precipitates are formed, they are also called as precipitation reaction, right? Now let's take an example. One of the activity which is given in the book, it says a metal copper when it is heated. Now normally or generally we can say when any metal is heated in air or it is burned in air, mostly the reaction with is oxygen. So this copper reacts with oxygen to form copper oxide. That is cupric oxide, right? Now the color of copper is generally brown. As you can see the copper metal in the wires which we use at our home. But when it reacts with oxygen, when we heat it with oxygen, it becomes black in color. Right? So what happened here actually, if we talk about reduction and oxidation, this copper reacts with oxygen. Now initially this copper was alone. There was nothing. Now what happened? This oxygen was added in it and this copper turns to copper oxide. So there is oxidation here. Right? If we go further in the reaction, in the activity is given, when this copper oxide, when hydrogen is passed over this copper oxide, hydrogen, what happens? Since hydrogen is more reactive than copper, it removes oxygen from it. So this is just a displacement reaction. Since hydrogen is more reactive than copper, it displaces copper from its salt. And what happens? What is formed? Cu plus H2O. Right? Now what happens in this reaction now? If you see here carefully, initially we had copper oxide and it formed copper. From copper oxide, copper is formed. What happened in this case? From copper oxide, oxygen is removed and what is formed? Copper. So that is why here we say it is reduction. This is reduction here. But on the other hand, initially this hydrogen was alone. Now what happened? It formed water. So oxygen got added to it. Oxygen got added. Addition of oxygen is there in hydrogen. So we say it is oxidation. Right? So this complete reaction is called a redox reaction because we have reduction also and oxidation also in this reaction. Now there are more things to learn from this reaction. Now since this thing has given oxygen, so this thing is also called as oxidizing agent. So the thing, see, whenever we have to tell about the element or the compound which is reduced or which is oxidized, we always tell from the reactants, right? And whenever we have to tell about oxidizing agent and the reducing agent, then also we tell from the reactants. We don't tell from the products. You can't say this copper is reduced or copper is oxidized, right? We will only tell from the reactants because initially we have these two things. So we tell from here only which substance is oxidized and which substance is reduced, right? Now in this case what happened? This copper oxide has given oxygen to this. It is given or taken, doesn't matter. But from here oxygen has gone to this, to hydrogen. It means this is given oxygen, so that is why this is called as oxidizing agent, right? And this hydrogen has taken oxygen. this hydrogen has taken oxygen from the copper oxide. So this is called as a reducing agent. Now we can have the definition of oxidizing agent. We can say oxidizing agent which gives O2, or we can say takes hydrogen, which gives oxygen and takes hydrogen. On the other hand, when we talk about reducing agent, we say it takes oxygen or it gives hydrogen. Right? So these are the oxidizing agent and the reducing agent. Let's understand with the help of one more example. There can be some confusion because already hydrogen is there. Let's take one more example from the book itself. Now what we have is given zinc oxide reacts with carbon to form Zn plus CO, that is carbon monoxide. Now zinc oxide reacts with carbon to form zinc and carbon monoxide. Now what happens? Just see again. Initially we have these two things. Out of these two things, this is having oxygen, this thing is not having oxygen, right? Now after the reaction, from zinc oxide it formed zinc. From carbon it formed carbon monoxide. Now I have four things to tell. First, which substance is reduced, which substance is oxidized, which is reducing agent, and which is oxidizing agent, right? So I write four things. Substance oxidized, substance reduced, then I say oxidizing agent, and then I say reducing agent. Now look carefully in the reaction. You see here we have zinc oxide. This thing is having oxygen, but after the reaction there is no oxygen in zinc oxide. It is left without oxygen, that is zinc, right? So it means what has happened, this zinc oxide, from the zinc oxide, oxygen is removed and it forms zinc. It means zinc oxide is a oxidizing agent, or we can say it is substance reduced, right? So substance reduced is zinc oxide. Substance reduced is zinc oxide, right? Now substance oxidized. Now initially you see this carbon was alone. This carbon is alone. Now after the reaction, oxygen got added to the carbon and formed carbon monoxide. Initially there was no oxygen. Now it has oxygen. It means the substance oxidized is carbon. So I write C here. Now very easy to write these two things. The substance which is oxidized is always a reducing agent, this thing. So I write carbon here. And the substance which is reduced is always an oxidizing agent. So I write zinc oxide here. So it's very simple. If you can find these two things, then writing these two things becomes very easy. Let's take one more example, one more activity. There is one more equation given in the book. MnO2 plus 4HCl, it forms MnCl2 plus water plus Cl2. Right? Let's see, in the beginning we have these two things. Now this thing is having oxygen, this thing is not having oxygen. Obviously, if we start from here, manganese dioxide, this is manganese dioxide, it is having oxygen. Now after the reaction what happens? From manganese dioxide it forms manganese chloride. There is no oxygen. There is no oxygen. It means this is the substance which is reduce. I write MnO2 as a substance reduced. I write here as reduction. Now on the other hand, it is not always about oxygen. It can be some other, because we have three definitions of oxidation and reduction. Now we see when this HCl, from this HCl what is formed? This chlorine. Now hydrogen was there initially, now there is no hydrogen. Initially hydrogen was there, now there is no hydrogen. And when we have also learned the definition of oxidation, that it is removal of hydrogen. So there is no hydrogen here, it means this is the substance oxidized. Right? Next thing, as I told, whatever is the substance oxidized is always a reducing agent. So I write this thing here, HCl, and this will come here, MnO2. So right here friends, this was all about the different types of reactions. I tell you once again, I will revise the reactions once again. The first was the combination reactions, a reaction in which two or more substances combine to form a new substance. Then we learned about decomposition reaction, a reaction in which a single substance breaks down to form two or more products, and the decomposition is can be either due to heat, it could be due to electricity, or it could be due to you can say sunlight also, or simple light also. Then today we discussed about displacement reaction, in which a more reactive element displaces a less reactive element from its aqueous salt solution. Then we discussed about a double displacement reaction, in which two reactants exchange their ions to form two new products. And then we discussed about the redox reaction, that is the reduction and oxidation reaction, and we have discussed about all the definitions, right? So this was all about the different types of reactions. Now next thing that comes, that is the last topic of this chapter and today's lecture also, is about we can say the oxidation, the use of oxidation, you can say use or what this oxidation does in our everyday life, right? So there are two things to be discussed here. Oxidation in our everyday life. We talk about the first thing as corrosion. Now when we talk about corrosion, corrosion is nothing, it's basically eating away of metals. Eating away of metal, it could be because of oxygen, it could be because of acids, it could be some other thing also, right? So eating away of metals is basically called as corrosion. And to understand more, I give you example, that is rusting of iron is a kind of corrosion. So when I write the definition, it is eating away of metals. Now this eating away of metals can be due to numerous reasons, right? But this eating away of metal is generally not beneficial to us, because when we talk about the one thing, that is rusting of iron, in that case what happens, we have a loss of huge amount of iron every year, because the iron is used in making bridges, iron is used in making flyovers, iron is used in making the railway tracks, right? So what happens in that case, this iron get rusted, so we have to remove, because the strength, because of the rusting, or we can say because of the corrosion of the metal, the strength of the metal decreases in some of the cases, right? As in case of rusting of iron. Now, when we talk about the case of rusting of iron, what happens in that case? The rust which is formed, if I tell you the formula of rust, the formula of rust is basically Fe2O3.XH2. Now this XH2O, X we don't know, it's the number of water molecule, how many water molecules can be there. But what happens in case of rusting of iron? If you have tried touching an iron, we can say iron substance which is already rusted, you can see there is some powder substance which gets in your fingers, which gets over your fingers. That is basically the rust. Now this powdered form, that is the rust, is very soft. So as soon as some water falls on it, or we can say if the air is moving very fast, so this rust gets removed. And then what happens, if this is suppose an iron article, there is rust over it. If I remove it, what happens? The inner part of the iron metal get exposed to the environment again, and then again the inner part of the you can say the metal gets exposed, and then it start corroding again, right? So slowly what we have, the metal it is eaten away. It is a long process, but it gradually decreases the strength of the iron. In some cases it can be beneficial also, like if we talk about you can say aluminium. Now in case of aluminium, what happens when this aluminium reacts with oxygen, it forms a layer of aluminium oxide. In case of aluminium, the layer of aluminium oxide is very strong, it's very hard, it remains stick with it, so the inner metal remains protective. Inner metal remains protective, and the inner metal you can say is not corroded, so life prolongs over it. But in case of rusting of iron, the life slowly decreases. Now we have some ways. There are some ways by which we can prevent rusting. Now, to prevent rusting, we have different things. We can use either paint, we can do greasing, we can do oiling. Like in case of cycle chains and the bikes and scooters, chains are there. We can do greasing and the oiling, right? Then we can also form alloys, and there are many other methods like chrome plating, nickel plating, right? These are the different methods by which we can prevent, we can slow down basically. Because if we have an iron grill at our home and we paint it, but what happens after 4 or 5 years, that paint gets removed and we have to paint it again. So this basically is helping. What happens in that case, actually, if we paint it, so there is no connection between the metal and the atmosphere in the environment. So what happens? The metal gets protective. The metal gets protected. Same way in case of if we are applying the grease, what we are doing basically, we are putting a protective layer between the metal and the environment, so the metal is saved. So this is all about corrosion and how we can prevent it. Next thing when we talk about oxidation in daily life is about rancidity. Now, what exactly is rancidity? Let's understand this. Now, this rancidity is related with the food articles containing fats, right? So, the fat in the articles reacts with the oxygen present in the air and they form rancids. And the overall process is called as rancidity. That is, the formation of rancid is called rancidity, or you can say the formation of, you can say the reaction between the fats present in the food articles and the oxygen to form rancids is called rancidity, right? Now, very few common examples. If you have seen a chips packet, any of the chips packet. Usually what happens if this chips packet comes at your home and it opens, it's over in we can say in a very short time. But suppose sometime you hide it from some of your family member, from your brother or sister, to eat it some other day, and you forgot, and you see after 1 month or 2 months, when you just see the packet, you can see the chips inside is moist and the smell and the taste is not good. So that what happens basically these chips contain fats, and these things react with oxygen to form rancids, and due to which the smell and the taste of the food articles changes, right? So this is about rancidity. Now the question, how we can prevent it? Prevention. There are very few methods for prevention. The first thing is the things, if we talk about the food articles which we get from the market, which are packed. Now they are flushed with nitrogen, especially your chips packets. Nitrogen is a very unreactive, you can say, or it has a very less reactivity, so it prevents the food articles in coming in contact with the oxygen. So that is why this nitrogen is, we can say, flushed, or we can say the food articles or the chips packets are flushed with the filled with the nitrogen gas, so that the food article doesn't react with oxygen. But it also has, you can say, some expiry date, because after that this nitrogen somehow, since it is a gas, can come out and the food article can degrade again, right? So this is one of the method by which we can prolong the life of the food article. Secondly, we can refrigerate. We can refrigerate the food articles, which we normally do at our home. And thirdly, what we can do, we can keep the food in the airtight containers. So due to airtight container, now what happens in case of airtight containers also? If you open once, some of the air gets inside. But when we close, since it is airtight, no more air gets. So simply what we are doing, if any of the food articles get spoiled in 2 days, we prolong the life, it can go to 4 or 5 days. So this is the use of airtight containers. So right dear friends, this was all about the chapter of chemical reactions, equations, types of reactions, balancing equations, and the use of, or we can say, the oxidation in our daily life. So right dear friends, hope you have enjoyed and understood everything in this topic. If not, just go and watch the video again, and make sure you like my video. So right dear friends, this is your host signing off. Goodbye and take care. Don't forget to subscribe. Okay, bye bye.